Hello, my name is Miss Lovey Math, and today we'll be talking about multiplying polynomials. So we will be going over some of the different ways to solve for it, the different types of polynomials, and how to multiply them. Definitely be going over a lot and definitely showing a lot of examples along the way. I got a total of 10 examples. If you want to know a specific technique or a specific just way to solve them, definitely check out in the description or check out the timestamps. I make sure to list them all for you. But in the meantime, I'm just gonna give a little description and then go over some of the 10 questions that I have. A quick little rundown of multiplying polynomials is so let's look at this example. For example, we have the 3 and the 5. They are coefficients. Just gonna write the abbreviation. Most likely your teacher has the longer version, but this is coefficients. And then the 2 and the 1 are the exponents. Exponents. So what we want to do is with the coefficients, we want to multiply them. So 3 times 5. As we notice, we have an x, so we're going to put the x right here. And for the exponents, those ones we want to add. 2 plus 1. And that's how we get our answer. It would be the same thing done for like longer longer polynomials. The key is just to remember um which which one to multiply and which one to add, as sometimes people do get confused by it. So here's another example. Well, you already guys saw the top, so 2 plus 1, but then it's multiplying. Then we're adding here because of that addition. Think of it as like distributing it. It's the same thing like when you did a distribution to like the plus or negative sign. So think of it like the same way. Now, 3 times 3x. Um, think of this one, just the regular 3 as 3x0, and think of that as just 3 times 1. So and then here's our answer. We will be going over plenty of those, so definitely stay tuned for that. But this is how it looks like, and it's also in standard form. So let's go on to question 1. First problem. So let's distribute this 3x to the bigger polynomial. What we end up getting is the following: 3x times x squared plus 3x times 3x plus 3x times 4. So just for reminders, just remember that this x, if it doesn't have a number, it's just a little 1. And when it comes to the 4, if it makes it easier for you, just remember that there's like an invisible x0, but remember that is just a 1. So let's do this. We're going to be multiplying its coefficients and adding the exponents. So we got 3 times 1 x, 2 plus 1. Then we got 3 times 3. Then 1 plus 1. Then 3 times 4. Then 1 plus 0. Now, after doing all this, we are left with 3x cubed plus 9x squared plus 12x1. Or just so you don't have that one, 3x cubed plus 3x squared plus 12x. This is the standard that teachers normally expect from you. As you notice, we also do have multiples of 3. Sometimes teachers like it when you reduce down. So we can do the following. We can do 3x plus 3 square plus 4x. Next problem. So we got 5, which wants to get the product of 3x squared plus 8x plus 1. Definitely, this one's a little bit more easier than question 1, so I probably should have done this one. But anyways, let's distribute 5 to these 3. So this is what we get so far. We get 5 times 3x squared, 5 times 8x, and then 5 times 1. Alrighty. Just remember of like the visible 0. Just to make it easier on us, I'm not going to write the whole situation because all we are multiplying times 5. So this is the answer. So 3 times 5 equals 15. 5 times 80 equals 40. And then 5 times 1 equals 5. Alright, and then that's our answer. Um, yeah, definitely. This is how people go for it. Like, if for some reason you did wanted to take the longer path, just show off the fact that 2 is gonna be added by 0. It really is just dependent on how it helps you memorize. So if you like this method, definitely go for it. I personally don't like writing it so long, so I just did this way, but some people might like it better this way. Up to you. Whatever gets you to the correct answer. That's all that matters, to be honest. So, if you like it this way, then you go that way. We're all here to learn in the end. Alrighty. Next problem. Alrighty. Now we got binomials. So basically, it has 2 coefficients for 2 polynomials. But okay, this one definitely has a few methods. I will be going over some of them the best I can. So, let's get to it. The first one I'm gonna show is personally my favorite method to do it. I've always used it. I used it throughout college. It benefited me the most. So, you don't like this method, there's more methods coming along the way. So we got 2x minus 5, and then got 3x plus 1. So what I personally like to do during college, I personally like to make cubes. It helped me to figure out which is which. So we got 2x minus 5, and then 3x plus 1. Now, since we are multiplying, we will be doing multiplying for each and every square. So 3x times 2x equals 6x squared. Remember, we are just setting an example for people that still need a reminder. We are multiplying the coefficients, and then we're adding the exponents. Just remember that. Next up, 3x times negative 5, we get negative 15x. 2x times 1, it obviously 2x, and then negative 1, no, negative 5 times 1, negative 5. And some fun thing about this is that you add anything that has the same um, x. So, for example, we have nothing familiar or nothing, no common like terms for 6x squared, so we leave that one alone. There are two for the x. There's 2x, and we got negative 15x. So that means we're going to add these two. And then negative 5, we just leave it that way. So that means we got this remaining 2x plus negative 15 plus 2x, and then negative 5. If you don't like the way that I wrote it, you can also write it this way. I personally I actually like the second method better. It helps me out easier. I just wrote it that way. It really, like I said, depends on how you want to write it. So if you like it one way or the other, feel free to pick one. So we are going to add these two, or add these two. Up to you. We got 6x plus negative 13x plus negative 5. Same thing here. 6 plus x, 13, negative 13x negative. As you see, we got the exact same number, or the exact same polynomial. Many teachers would accept this as an answer. If you like it to look much nicer, you can. Oh, give me a second. You can leave it like this. Definitely talk to your teacher to see which one they would like more. They both mean the exact same thing. Up to you. But this is my method of how I like to do the multiplying polynomials once it got farther than one. So up to you if you like to do it this way. But I'll definitely show you another one. Next one is the FOIL method. We're off to do the FOIL technique. And you might be wondering, why is it called that way? You'll see in a second. So, as you see, we got binomials. Both of them are binomials. So, this is a perfect problem to do the FOIL technique. So the F stands for the first terms. We need to multiply the first term. So the first terms that we got are 5x and 2x. So we'll set this to the side right now, just so everybody can clearly see which is first. Next, we got the O, stands for outside. So like the most far distance ones. So we got this one and this one. The 5x and the plus 2. Plus 5x times 2. Then we got the I. The I stands for the insides. So basically the ones closest to each other. So we got the 3 and we got the 2x. So 3 times 2x. Lastly, we got the L. It stands for the last term. So we got the 3 and the 2. So 3 times 2. And that's how it goes. Let me just write it like in kind of like a downwards area just so everybody can see which goes first. First, outside, inside, and then last. Like I said, this is a method that particularly works only if you have two binomials. You can't really use it with the other ones. It just makes it easier. And yeah, so now let's multiply them. So we got the 5 times 2, then the x, and then we got 1 by 1. 1 plus 1, then we got 5 times 2, x, 1 plus 0, then we got 3 times 2, then we got 0 plus 1, and then we got 3 times 2, and there's no exponents for that one. So that one's going to be equal to 1. Alrighty. So our answer is going to be 3x squared plus, 10x squared plus 10x plus 6. Wait, this isn't our answer yet. My bad. But at, after this, we need to combine like terms. So we got 2 x's. So we are going to add those up. So now this is the final answer. 10x squared plus 16x plus 6. And this is the final answer, and this is how you use um, the FOIL method. I will most likely go over more in detail because there is a particular graph that tends to be shown with this one. But basically, this is the routine, or this is how it would normally go with this type of answer when it comes to the FOIL. So off to the next. When it comes to this particular problem, we are doing the product of a binomial with a trinomial. So it's a little bit more difficult. I'm gonna show two methods about going it. Definitely feel free to choose whichever you like. But for this particular problem, I'm gonna be showing my method of how I tend to do it. So going back to the squares for this one. Alrighty. Made them bigger than I needed to, but hey, the space is always useful. So as you can see, I wrote it this time in a particular way. It doesn't matter how you draw the squares, so you can even draw them like this. It's up to you. I personally just having the longer side be the top instead of the side. So let's input. So we got to put the trinomial at the top. So the 3x squared plus x plus 4. And then we got x plus 7. So x plus 7. Just going based off the third problem, we're just literally just multiplying which is which. So 3 times 1 equals 3, and then the exponent of 2 plus the exponent of 1 is 3, so we got a 3x cubed. X times x, or the exponent of 1 plus 1 equals 2, so we got 2, and then 1 plus 1 equals 1. So you can either leave a 1 or just leave the x the way that it is. And then x times 4 is just x4. Just if, like I said, if you tend to forget it, just imagine this is an invisible one. So there's that. We got 3 times 7, so it's 21, and then the 2 plus 0, 2. So there's that. Then we got 3 times x. 7 times x, so it's 7x. And then 4 times 7 equals 28. We have definitely a lot of like terms. I'm gonna circle the ones that are the same term. So we got the x squared and the x. So we're gonna combine these like terms. So 3x plus 3x cubed, not x squared, 21 x squared, x squared plus 7x plus 4x plus 21. Alrighty. As I said, we have definitely two, well, four that can combine into two that are like terms. So let's add those up. 3x cubed plus 21 plus 1 equals 22x squared. And then 11 plus 11, wait, 7 plus 4 equals 11, and then x and 21. And that's how we get the answer with this particular method. I'll be going off to another method for the next problem. Okay, so this is our next problem. So we got 2x minus 7. Trying to get the multiply this by x squared plus 5x plus 2. So this is a different method for it. So what we want to do is we want to distribute the binomial to the trinomial. So we are going to multiply the trinomial with each term of the binomial, which helps the distribution. So we're going to separate the binomial into two. 2x times the trinomial plus negative 7x. There you go. This helps us make it much easier for us to figure out who distributes to what. So now what we're gonna do is distribute the 2x to the trinomial, and then the negative 7 to the trinomial. So now we got the following: 2x times 2 square, 2x times 5x, and then 2x times 2, and 7x negative 7 times x squared, negative 7 times 5x, and then negative 7, negative, and positive 2. Alrighty, definitely longer, but we will definitely shorten it down as time goes on. So now we are going to multiply the coefficients and add the um, and then add the exponents. So 2 times 1 equals 2, and then 1 plus 2 equals 3. 2 times 5 equals 10, and then 1 plus 1 equals 2. 2 times 2 equals 4, and then we got a singular x. Then we got negative 7 times 1 equals negative 7. Then just a singular negative x squared. Negative 7 times 5 equals negative 35, and then we got a singular x, and then negative 7 times 2 equals 14. Going based of what I can see, we definitely have a lot of common line terms, so let's highlight which one's which. So we got this one, we got the x squared, and we got the x. So we are going to combine these two and these two. So now for our final product, we got 2 plus x 2x cubed, and then we got negative 7 because 10 plus negative 7 equals negative 3 x squared. Then we got negative 11 because negative 31 I meant. Negative 31 plus 4 equals 31. Leave it the same. And then we got negative 14. Leave it like that, or you can put it like this. Either one is correct. Up to you. For number 5 and number 6, it really is dependent on how you want to put it. So definitely your choice. Now we got something relating to the square. So let me go into more detail. So this one in particular means that these two are the exact same binomials, and we need to multiply them by both. There's a few methods to go with it. Today I'm going to be showing two. I'm going to be showing you the square of the binomial sum, and then once again my own method that I like to use. For this one, I'm just gonna show the way that the formula like tends to look. So how it goes is that imagine that this is a plus b. How it goes is that the first we multiply 2x the same, then it's 2ab, so you're multiplying a and b, and then you got the b square. This is the formula that tend to be used when it's the exact same binomial getting multiplied. So let me show you in this particular form. Question. So I'm gonna multiply this. So as we can see from this formula, a equals 2x, and then b equals 5. So we're just gonna input this. So 2x squared plus 2x times 5, and then same thing, 5 squared. Now we're going to do the coefficients of it. So we're gonna do 4x squared plus 20x plus 25. If you were confused on how we got this to this, so like just remember that this is what's happening. So we're multiplying it by itself. So that means we have 2 times 2, and then x, and then 1 plus 1. Just for the people who might confuse how we got that. But it's that easy when you use this particular formula. So this is our answer for number 7. Our very last problem of this video. So we got the same thing like what we did in number 7. This time this is my own method. So definitely it's the squares already. Oops, my bad everyone. So as we all know, this is the exact same binomial, just just written differently. So we got 6 times 6 equals 36, and then negative 4x times 6, negative 24x, then the same thing, negative 14x, and then 4 negative 4 times negative 4x minus times negative 4x is 16x squared. So let's bring this one down. As you can see from the image, we definitely have 2 common like terms. So we're going to add that, and I'm going to also make it in standard form just to make it much more easier for you to understand it. So just hold on for a second. So we got 36 plus negative 48 no x, because we're combining like terms, we're not multiplying, and then plus 16x. Now for standard form, we're just going to make the bigger degrees first. So there you go. Definitely, if you can leave it like this, talk to your teacher first about it. But this is how it is in standard form, so this is how I'll be leaving the answer like that. But thank you so much for watching this YouTube video, everyone. I really do appreciate it. If there's more problems that you want me to do based on this topic, definitely let me know. If you have some homework problems and you'd like me to do a video, definitely let me know. To a certain extent, obviously, learning is the only best way for you to. Doing mistakes is the only way you learn how to do it right. If you can make mistakes, then that's perfect, because that way you'll learn and get smarter every single day. I wish y'all nothing but the best. And definitely check out any other video that you see that could really benefit you for your math career. But have a nice day, everyone. This has been Miss Lovey Math.